Next up, we'll hear from Scott Chamberlain. Scott is an entrepreneurial fellow at the ANU College of Law. Scott will join us remotely, and he will introduce Evernode, a proposed Layer 2 dApp platform utilizing the XRP ledger. Scott is also a University Blockchain Research Initiative, better known as UBRI, partner. UBRI is a global partnership with universities to support research, curriculum, and education into fintech, including cryptocurrencies and blockchain. Scott has presented at UBRI Connect the past 2 years, and his research has long been focused on the impact of blockchain on the law. Here's Scott.
Well, welcome from sunny Australia. I'm Scott Chamberlain. I'm talking today about our Evernode project, and I'm just the blind man describing the sun that's leading the project. Behind me are the two far more important and technical people. Richard Holland, who most of you will know from his Toast Wallet days, who's now with the XRP Labs boys, is the kind of genius and technical lead. And then we have Ravin Pereira, who's leading the small team of coders at an outfit called Gevio. They were clients of mine before I became an academic. And the reason why I mention Ravin is important for you guys watching to know that there is this project is resulting in another team experienced in building on the XRP ledger. And I think that's pretty exciting. So Evernode is a global, permissionless, flexible, fast, scalable layer 2 network of hot pocket nodes. It's composed from the XRP ledger. It's incentivized for hosts to run dApps, but it needs DEX and the hooks. And what I'm going to do today is unpack each of these statements. First, the current state of play. We have something that is global, flexible, fast and scalable, but at the moment it's 100% permissioned. This is our current global cluster, 40 node global cluster, and we've got it cranking over at a 2-second round time. You can see we've gone and purchased hosting services at various data centers around the world, the cheapest ones we could find. And we're driving it quite quickly at 2-second round times to see how it might break. This is a NFT contract running on the cluster. You select your input, you can see the green there, that's it going into consensus, coming out of consensus, and we've generated an NFT certificate as an Evernode, a supporter of the Evernode project. Let's have a look at this behind the scenes. The Everdog NFT contract that's running on this 40 node cluster. What we've done, we've got 12 images. We've uploaded it to the cluster. Each image is twice as rare as the preceding image. And the contract that's running on this cluster, it's written in Node.js. We've got all 12 images stored. It applies the rarity rules to select an image, gives a certificate, sequential certificate number, generates the QR code, then generates the JPEG to download. And we could store the image on chain quite easily, but we don't because of resource constraints. We're running the cheapest machines we can. But if we did do that, the QR code would then be a pointer to a unique and persistent image that no one can delete. This is an innovative way of doing NFTs compared to the existing technique of just having a pointer on chain to somewhere off chain. How do we do this? What's under the hood that's making this work? This is the network of hot pocket nodes that connects our 40 node cluster together. Hot pocket, Evernode's beating heart. It's a UNL consensus protocol that enforces rules on inputs and outputs, maintains a shared canonical state across the nodes. It has some rapid state sync functionality, a bundle of features that make it as easy and fast as possible to spin up a new node and for that node to sync to the network. We've got some contract life cycle management features. The devs talk about it in terms of the contract lives amongst the data, and therefore we can make sure contracts are similarly configured and we can upgrade them at consensus. We've got a daemon that coordinates everything from a central message board, and we've done what we can to make sure it's minimal setup, so it's as easy as possible for people to create new nodes. And the technical specs, you can see those on the screen, C++. We haven't driven it as hard and fast as we can, so these are still a little bit rubbery, but this protocol runs on any Linux machine at the moment. That's the protocol. So there's a couple of things we had to do to stitch it together into a network. We begin at point one, where you've got a smart contract that's applying rules to inputs and outputs and maintaining a persistent state. In the second phase, we've got Hot Pocket as a consensus layer that links each of those smart contracts together so that we're running the same rules and the same canonical state on multiple machines. And then in the third iteration, we've now got our Sashimono network, where all of that is being coordinated from a central or decentralized from a single message board. And you can see there that we've got 3 Linux hosts, each of them potentially running different DAP instances, all of it being coordinated through the Sashimono agent. What we get with this technology is we get dApps that don't run on blockchains, they are blockchain. Each DApp on the network would be its own blockchain with its own chain history. We get incredible flexibility. The dApps can be public or private. They can call external services, read and write data directly to disk and web, and generally perform any task that a regular program could perform. And we do that without centralization or trusted third parties. And we can do that without the programmer having to implement their own consensus mechanism. You simply host your dApp on a Hot Pocket enabled node, and it does the consensus for you. In terms of benefits, we get improved privacy compliance. We get dApps that can encrypt data or can only run on hosts with required privacy features, such as in particular jurisdictions. We get scale and flexibility. You can run your dApps on as few or as many hosts as desired. We can have things like on-demand oracles. The dApps could elect a jury of their peers to go out and get off-chain data and agree on the truth and feed that data back to the nodes. And we get enhanced security. It's possible for the dApps to detect when one of their nodes has become unreliable and shut down that instance and reload it on a new, more trusted node on the network. We have successfully used this technology to build a number of prototypes, the most sophisticated one at the moment being our IXRPL self-KYC identity solution. We also have built a digital cows, a 24/7/365 cow platform for trading digital interests in Australian cattle. And I won't go into those in detail. There's a link there in the slide for those of you that want to have a look at those projects in detail. We have this fantastic tech that's very, very flexible in terms of what it can do in a decentralized way, but it's not decentralized itself. At the moment, every single instance is spun up by the same entity. So while it runs on multiple machines in multiple locations, each of those machines is controlled by a single entity. So we need to get to the point where this is a decentralized network. And the first step there is to have it composed from the XRP ledger. So you remember this diagram of the Sashimono agent, and it's coordinated from a decentralized message board. Now that message board could be anything, could be any layer 1 protocol, could be a machine in someone's basement, but our vision is to have it coordinated from the XRP ledger. The XRP ledger has a number of benefits of which everyone watching this presentation will be aware. It's speedy, cheap, reliable, secure, and it has a native decentralized exchange. From our point of view, we also get a number of benefits if we can use an existing ecosystem. We get integration. We avoid the need to build an independent ecosystem of wallets, browsers, plugins, and explorers. So Evernode could be its own separate, completely separate ecosystem, but we'd have to build all those things to make it work. The second problem is that we avoid is that we don't have to have our own separate DUNL. We don't need a default UNL because there's a lot of complications that come with that, with specifying it, identifying it, incentivizing it, and making sure that it's decentralised and it doesn't look like it's just one entity choosing everybody who's on the list. So to have an existing infrastructure that's already got its DUNL, that's already been persistent and is reliable, is an incredible benefit for Evernode as a project. So we can get to the point of having these clusters coordinated or composed from the XRP ledger. We could kind of do that today using an existing XRPL account. But the problem is we don't have any way then of incentivizing the hosts to exist. And one of Ethereum's greatest assets is that it exists. It's this incredible network of machines that you can upload your smart contracts to without asking anyone's permission. But there is already, this enormous network of machines in existence. And for us, there's a bit of a chicken and egg problem of having the machines already there for people to upload dApps to in advance of there being an ecosystem of dApps that want these machines to exist. And so to do that, we're planning to have a native token for the network. And what the token is used as a way of incentivizing hosts to exist, to reward them or effectively pay them to exist in advance of there being dApps to run on these networks. So in advance of a fee network. And I have to just mention, because we're talking airdrops, the mandatory Seagold dispersion notice. There's no Evers yet, there's no trust line, there's no airdrop yet. This is our current plan. It might change. No one knows anything yet, including us, in terms of with certainty. And I just need to say that because talk of airdrops leads to an endless list of requests of when trust line. The second aspect of the incentivization isn't just the Evers, but hosting tokens. So we're going to, these are kind of NFTs that the hosts mint, and they represent a promise to deliver hosting services. So the way we envisage it working is that the hosts mint hosting tokens, and these are traded on the XRPL's DEX for Evers, and then the dApps redeem those hosting tokens for the hosting services. So we get a market for hosting services. It's a way of turning what is a non-fungible product, hosting services on a particular host, into a fungible, tradable kind of service. So that looks nice and simple. Hosts mint tokens, dApps buy the tokens using Evers, and then dApps redeem the tokens for hosting services. Unfortunately, it's a little more complicated than that. And for our vision to be fully realised, we need the DEX and we need hooks. This is our current map of the various transactions and trust lines and offers and check transactions that need to happen for the system all to be stitched together. You can see that we've got, there's a hosting journey for the tokens. Host mints the tokens, lists them on the DEX, the users buy the tokens, they then send the tokens back to the hook to redeem the tokens in return for hosting services. We've had to map out in detail each of the reserves that are necessary for people to have accounts on the XRP ledger, and then each of the reserves necessary to open the various trust lines. And the Evernode hook itself has reserves that it needs, plus it needs a state reserve. There's a fee for maintaining the state. So I won't go into this in detail, but we will look at, just quickly, we need obviously a process for host registration, whereby hosts run the Evernode code and then tell the hook that they want to be part of the Evernode network and to receive Evers in return for their services. We have a process whereby those hosts then mint tokens that represent their hosting services and list them on the DEX for trade, and people that want hosting services buy those tokens from the DEX. The really nifty thing we discovered in this process is that the DEX when you buy the token from the DEX, the trust line is automatically created from your reserves. So that's an extra step that was automated, which was nice. Having bought your tokens, you then need to redeem them. And the process that we've got is that the user redeems the hosting tokens through the Hook account. And in this way, the Hook manages the redemption of the tokens. It's a way of checking that you're actually, getting services for your redemption. There's this audit process, and I just want to pause to have a little explanation of this particular function. This is the rubbery. Oh God, this is the least certain aspect of our current model. We know that we need a process for confirming that hosts are real, that they are delivering the services they promise that they deliver. And so what we have is this idea of an auditor and it could be more than one, could be multiple auditors throughout the network that run contracts on the hosts. And when those contracts run successfully, the Hook is told that those contracts have run successfully, and that becomes the trigger for the distribution of the Evers rewards. The way we have envisaged this at the moment is that hosts send hosting tokens to the Hook, and the Hook then chooses randomly hosts to get audited through a provably random process, and it sends those tokens to the auditor, who then redeems them for the hosting. And so we get this randomized audit. Now we could, it's probably going to be technically infeasible to audit every host all the time. We could audit hosts randomly, say 10% of hosts might be audited each moment, each reward period, and those are the hosts that get the rewards. Or it could be that you get the rewards regardless and you're audited randomly, and if you fail an audit, you simply miss out on hosting rewards for a period. This is the part of the model that's going to most change as we move forward in our development. If we can make it all work, we get this, the combination of hooks plus the decentralized exchange means we get a completely decentralized Evernode network. We've got a process then for incentivizing hosts to exist by issuing Evers from the hooks. We've got a process for policing the hosts by the randomized auditing. We have a way to facilitate the hosting market by exchanging Evers for hosting tokens on the DEX. And we've got a process for managing the redemption of the hosting tokens for hosting services. Importantly, what happens there is that the tokens get sent by the user to the Hook, and the Hook waits until the host spins up an empty instance for the dApp to run in before redeeming the token with the host. And all of this happens without, the Hook is the middleman. The Hook is the automated middleman in this process, and that the code is public and it's open source in that sense, and freely available for people to investigate. There's no secrets. We are making progress towards this wonderful vision. In terms of our roadmap, we've completed Hot Pocket, we've completed Sashimono, the hooks are up on the XRPL testnet, and we're currently at the stage of integrating what we've built with the XRP ledger. In terms of the successful hooks integrations, we've been able to register the host with the Hook. We've completed the process of minting and listing the hosting tokens on the DEX. We've successfully done the purchase and redemption of the hosting tokens through the Hook. We have done a provably randomized audit of hosts, so that whole process of taking hosting tokens randomly, selecting those that should be audited, sending them to the auditor, having the auditor redeem those tokens in return for running an audit contract on a host, and the distribution of the Evers rewards. What we've got left to do is to take all of this and develop it into a functioning Evernode toy, so that we've got a complete version of what we want to do that we can play around with. And that's a process that's going to take us between 1 and 2 months before we can announce that we've achieved that milestone. But if we can get there, we get to where we wanted to go, which is a global, permissionless, flexible, fast, scalable network of hosts, all configured to do an incredibly wide range of dApps coordinated from the XRP ledger. We'll be able to do NFTs and tokenized assets, oracles, cross-chain interoperability, DeFi, gaming metaverses, self-sovereign identity, decentralized social media, AI and machine learning. All of these are things that machines can do, and with Evernode, you'll be able to do them in a decentralized fashion, coordinated from the XRP ledger. And that's Evernode for any dApp, for anyone, forever. Thank you.